If p is less than or equal to 0.05, that'll mean that the test is significant, which for the chi-square goodness of fit test indicates that there is a significant relationship between gender and aggressive driving behavior. If p is greater than 0.05, on the other hand, that indicates the test is not significant, meaning that there is not a significant relationship between gender and aggressive driving behavior. Well, with a p of 0.005, notice that it does fall into this first condition. It's less than 0.05, indicating that the test is in fact significant, meaning there is a significant relationship between gender and aggressive driving behavior. And if there is a significant relationship between these two variables, as we found in this case, one way to think about this is that indicates that one of the two genders tends to engage in aggressive driving behavior more than the other gender. If we move up to our previous table, where it says gender by, that's an asterisk, we read it as gender by aggressive driving cross-tabulation. And notice here, our row variable is the gender, so we have males and females, and our column variable is aggressive driving, where we have yes or no. So for our count, these are the values we entered into SPSS. We have 25 males who engaged in aggressive driving behavior, and 75 males who did not engage in aggressive driving behavior. And we have 10 females who engaged in aggressive driving behavior, and 90 females who did not engage in aggressive driving behavior. So these are our counts. This is what we entered into SPSS originally. You saw these counts in our data view window at the beginning of the video, under the column frequency. The expected count is what we would expect if there was no relationship between the two variables. And to see how the results turned out, we want to compare the expected count to the count. So recall that expected count is what we would expect to see if there was no relationship. Since the test is significant, we want to see how the count departed from the expected count in order to interpret our results. So notice for expected count for aggressive, we expected 17.5 males to fall into this category, and we expected 17.5 females to fall into the aggressive category as well. Notice how these are equal, which is what we would expect if there was no relationship. It's both 17.5. And in case you're curious, the way that's found for this example is, notice we have a total expected count of 35, and that's just divided evenly or split evenly between the two. But to understand our significant results, the nature of those results, we want to compare, once again, the expected count to the count, what we actually saw in our study. So when we have the 17.5 expected, you want to ask yourself, did we actually see more aggressive male drivers or fewer than expected? Well, we expected 17.5 and we saw 25. So this indicates there were in actuality more males who engaged in aggressive driving behavior than expected. And in fact, if you did the subtraction, we would see that there were 7.5 more males than expected. Now let's move to females. For females, once again, we saw 10, but we expected 17.5. So you want to ask yourself the following question for females. Were there more females who engaged in aggressive driving behavior than expected, or were there fewer females who engaged in aggressive driving than expected? And here, since we saw 10 in our study and we expected 17.5, this indicates that fewer females engaged in aggressive driving behavior than expected. If we move to the not aggressive column, we'll find the exact opposite pattern, and it's actually redundant. So we really don't need to interpret this, but I'll just do it very quickly so you can see that that's the case. So notice here we had a count. There were 75 males who were not aggressive, but we expected 82.5. So there were fewer males who were not aggressive than expected. And here we see there were 90 females who were not aggressive, and we expected 82.5. So there were more females who did not engage in aggressive driving behavior than expected. But this is really just describing the other side of the coin. And instead of describing not engaging in aggressive driving behavior, we'll just focus on those who did engage in aggressive driving behavior. And once again, we saw that males tended to engage in aggressive driving behavior more often than expected, while females engage in aggressive driving behavior less often than expected. And in fact, when we selected the percentages for the row, when we were choosing our options in SPSS, when we clicked on the cell button, you can see the percentages here of each gender who engaged in aggressive driving behavior. And this indicates here that 25% of the males engaged in aggressive driving, whereas 10% of the females engaged in aggressive driving. Whereas 10% of the females engaged in aggressive driving. And if 25% of the males engaged in aggressive driving, that would indicate that 75% of them did not. Whereas if 10% of the females engaged in aggressive driving, 90% did not. But since we're focusing on this aggressive column, we could say that there was a significant relationship between gender and aggressive driving behavior. And you should see from this table discussing the relationship between the count and the expected count. Males engaged in aggressive driving behavior more often than females. And we could add that 25% of the males engaged in aggressive driving behavior, whereas only 10% of the females engaged in aggressive driving behavior. And in fact, we can characterize the chi-square test of independence not only in terms of whether it measures if there is a relationship between two variables or not, but we can alternatively describe it as a test of what's called the homogeneity of proportions. Now that sounds like quite a mouthful, I'm sure, when I say it, but homogeneity really just means equality statistically, so equal. And then proportions, we can think of those, or we could convert them into percentages. Proportions are just decimals. We convert them into percentages, so we could say that the chi-square can also be viewed as a test of whether percentages are equal. And what we mean here is, it tests this in a nutshell. This 25% versus this 10%. If the test is significant, and we saw it was here, then that means that these two percentages are, in fact, significantly different. So 25% is significantly different from 10%. In other words, males engage in aggressive driving behavior at a significantly higher rate than do females. In fact, the rate is 25% as compared to 10%. Now, it's up to you whether you want to look at the test that way, but it is a completely valid way to look at it. Some may emphasize it testing whether there's a relationship, and others may emphasize it testing whether the proportions or percentages are the same across the categories. But either way, the results mean the same thing. If there is a relationship, that means in this case, males tended to engage in aggressive driving behavior more often than females. And if the proportions are significantly different, or the percentages, that means the same thing. In this case, it means that males tended to engage in aggressive driving behavior more often than females. Next, let's go ahead and write our results in APA format.